Okay, we're going to finish off Chapter 7 today, and we're going to be looking at Section 4 of Chapter 7, where we're going to be solving quadratic equations. Okay, that's going to be what the focus is on this particular section here. So we're going to take a look at solving what we call quadratic equations. Now, you have already seen how to solve linear equations. All right, that's what we began with way back in Chapter 2. So here in Chapter 7, Section 4, we're going to finish off solving what we call quadratic equations. And in order for us to solve quadratic equations, we need to use what we call the zero product property. Now, it's very important that we understand what this property is going to be telling us. The zero product property tells us the following, that if A times B equals 0, then what we'll be able to say is that A equals 0 and B equals 0. Okay, that is our zero product property that will allow us to solve quadratic equations. That if we have a quantity A times a quantity B, that's what's meant by the product, if they in fact equal 0, then we could say A equals 0 and B equals 0. Okay? For example, let's say we have x times x minus 3 equal 0. And we want to solve for x. What we're going to do is we're going to set the first part, x equal to 0, and then we're going to set the second part of x minus 3 also equal to 0. And now we have to solve for each x. Well, there's nothing to solve for here. X equals 0. That's one solution. To get this x by itself, of course, we would have to add 3 to the other side. And in doing so now, we would have x equals 3 as our second solution. And you must give me both solutions in order for it to be correct. Let's try another example. Let's say we had x plus 4 times 2x minus 1 equals 0. This is another case where we would be using that zero product property. The fact that it equals 0 and we have a product of two algebraic expressions, once again you're going to set the x plus 4 equal to 0, as well as we will set the 2x minus 1 equal to 0. And of course now we have to solve for each of these x's. To solve for the first x, I would want to subtract 4 over, giving me x equals negative 4. The second one, I would want to begin by adding the 1 over, giving me now 2x equals 1. And since we want just x by itself, I would have to divide both sides by 2, and therefore x would also equal 1/2. So we have, once again, two solutions for the variable x, and you must give me both. Okay? Now, in these particular cases, these problems weren't too difficult, because what do we notice here is that we in fact already have the product of these two algebraic expressions. What we have is the factored form of the equation. But what if we don't have an equation that's already in factored form? What you're going to have to do is you're going to have to solve by factoring. Okay? Our goal is to get it into the form where we can use and apply that zero product property. This is just one of the key things where we use factoring. All right, for example, let's say we have x squared minus 5x plus 6 equals 0. Well, we always want the equation to equal 0. That's a must. After all, that's why we call it the zero product property. So the fact that it equals 0, but here the problem is we don't have a product of algebraic expressions. So the first thing that we're going to have to do is we will have to factor. So you want to go through all of the steps of factoring that you learned in the previous part of this chapter. Descending order, your leading coefficient should be positive. If there's a greatest common factor, you want to factor it out. If it's a 4-term polynomial, you factor by grouping. If it's a trinomial, you use one of those techniques. Or if it's a binomial, you use the last technique that I showed you in section 7.3. Well, in looking at what we have here on the left side of the equation, it is a trinomial that is in fact factorable. So I'm going to set up my parentheses. It's actually the easier kind of trinomials. The factors of x squared, x and x. What do I know about my signs? Well, the signs have to be the same. Because of the plus sign, we need two negative numbers. So I'm going to put a minus sign here and a minus sign here. And now I need to think of the factors of 6, two negative numbers that multiply to 6 and add up to 5 would have to be 3 and 2. And now that we have the factored form, I could now use the zero product property, in which case I'm going to set the x minus 3 equal to 0, as well as I will set the x minus 2 equal to 0. And so now to solve, I would add the 3 over, giving me now x equals 3 as my one solution. And if I was to add the 2 over, now we get, of course, x equals 2 as our second solution. Okay? So here we had to do a little factoring first before we can actually go to solve this particular equation. Okay? Your goal, once again, is to ultimately use that zero product property. Once you have the product of algebraic expressions, you set them each equal to that 0. Let's try another one. Let's say, for example, we had the following. X squared minus 8x minus 48 equals 0. Now, once again, the first thing that we're going to have to do, it already equals 0. That's half the battle. Now, of course, we have to take a look and try to factor this down. Once again, I will set up my parentheses. The factors of x squared would have to be x and x. Now what do I know about my signs? Well, because it's a minus 48, I know the signs have to be different signs. One will have to be plus, the other is minus. And so now I need to think of factors of a negative 48. Two numbers that multiply to negative 48. One will have to be negative, the other will have to be positive, and they have to add up to a negative 8. Well, the two numbers that I think of would be a positive 4 and a negative 12. Now that we have the factored form of the original polynomial, we can now go and use that zero product property, whereby I would set x plus 4 equal to 0, as well as the x minus 12 equal to 0. Here are my two equations that I must now go and solve. I will, of course, subtract 4 from both sides, giving me my first solution of negative 4. And then I will add the 12 to both sides of the second equation, giving me the second solution of a positive 12. Those are the two solutions, two values of x, that if I was to plug them back into the original equation, they would in fact equal 0. Let's try another one. Let's try one that's a bit more challenging. For example, let's say we had a 6x squared equals 5x plus 4. And of course, we want to solve for x. Well, before we do anything, I notice that this equation does not equal 0. And since I know ultimately I want to be able to use that zero product property, I need this equation to be equal to 0. So what I'm going to do is I'm going to subtract 5x on both sides, as well as I will subtract the 4 on both sides. Keeping in mind that I'm going to write this polynomial in descending order, that would give me a 6x squared minus 5x minus 4 is now going to equal 0 as we had hoped. Okay, because remember, you want your equation to equal 0. Now here comes the factoring part. Okay, for this particular problem, this is the more difficult kind of factoring, all right, in terms of the trinomial. So let's go over how we're going to factor down this trinomial. For this, I used that borrow and give back method. I am going to multiply the 6 with the 4, which means I now have x squared minus 5x minus 24 equals 0. And now I turn this into an easier type of trinomial. So I'm going to factor this down. I'm going to set up my parentheses, x and x. I know I need different signs, and I need factors of the negative 24 that would add up to a negative 5. That, of course, would have to be 3 and 8. Okay, but now here comes the give back. I have to give back that multiplication of 6. So remember, to give back the multiplication of 6, I will now have to divide both of these numbers by 6. Simplify, I would have x plus 3 over 6 is 1/2, x minus 4 over 6, that 2 can be simplified into 4/3. It is customary, as we did in the past, to get rid of the fractions. So we are going to bring up the 2, as well as move up the 3. So the factored form will read 2x plus 1 times 3x minus 4 equals 0. That is the factored form of the original polynomial. Now that we have the factored form and the fact that it already equals 0, that's when we can now go and use the zero product property, in which case 2x plus 1 equals 0, as well as the 3x minus 4 would equal 0. To solve now for x, I'm going to minus 1, giving me 2x equals negative 1. And when we divide by 2, we get x equals a negative 1/2 as one solution. For the second equation, of course, we add 4 over. That, of course, would now give us a 3x equals 4. And when we divide by 3, we get x equals 4/3 as our second solution. Okay? So we still get two solutions. This one required a bit more work. First, we had to get the equation equal to 0. Very important. Then we had to do a bit more difficult kind of factoring, the trinomials where your leading coefficient is not 1. Okay? But then ultimately we go and use the zero product property in the end. Let's take a look at another one. Let's say we have a 3x squared plus 7x equals 0. Now I want you to think about all your different steps of factoring, okay? And what we want to do here in terms of factoring is we want to factor out a greatest common factor. Here, between these two terms, we in fact have a greatest common factor of just x. And if I factor out an x from the first term, I am left with 3x. And if I factor out an x from the second term, we're left with plus 7. So now I have x times 3x plus 7 equals 0. Once again, it's at this point where we can use the zero product property. that x equals 0 and 3x plus 7 equals 0. Well, there's nothing to solve here. In the second equation, I'm going to subtract 7, giving us now a 3x equals negative 7. And when we divide both sides by 3, we get x equals a negative 7/3 as our second solution. What about a problem like this? Let's say we had x squared minus 49 equals 0. Well, this was the last type of factoring that we did. This was the difference of two perfect squares. And so this is in fact factorable. We would factor it down with an x and an x. If we follow the formula for the difference of two perfect squares, we know one would be plus, the other minus. And so the factors of 49 would have to be 7 and 7. And it's at this point, once again, where we would use that 0 product property. So we set x plus 7 equal to 0, as well as x minus 7 equal to 0. By subtracting 7 on both sides, we get our first solution, negative 7. And as we add the 7 on both sides, that of course gives us the second solution of 7. So we're still coming up with two solutions. Okay? Now sometimes we have to get the equation ready for solving, ready for factoring, ready for that 0 product property. Let's take a look at some more difficult problems just because more steps are involved. And whenever you have more steps, that means that there's more room for some careless errors. So do be careful of them. First of all, let's say we have the problem x minus 6 times x plus 1 equals 8. Well, the common wrong thing to do, what you don't want to do, is students sometimes look at this and they're like, oh gee, let's set x minus 6 equal to 8 and x plus 1 equal to 8. Okay, because we have a product here, so we'll set each of these terms, like we did prior, equal to the number here, which happens to be 8. But that's incorrect. Okay, remember what the property was called. It was called the 0 product property. There was not an 8 product property. So we don't want to set just these factors equal to 0, unless we want to get it wrong. But who wants to do that? Instead, what we're going to do is we will perform the multiplication on the left side. So let's FOIL that out. And if we were to FOIL that out on the left side and combine like terms, we would now have x squared minus 5x minus 6 equals 8. But now we have to get a 0 on the right side of the equation. So I'm going to subtract 8 over, producing now our new and improved equation of x squared minus 5x minus 14 equals 0. Now we have created an equation that is ready for the 0 product property because we're going to have to factor. So let's set up the parentheses. Factors of x squared, x and x. What do we know about the signs that go on the inside? Well, they have to be different signs. One plus, the other minus. And factors of a negative 14 that would add up to a negative 5 would have to be a positive 2 and a negative 7. It's at this point where the 0 product property applies. So I'm going to set x plus 2 equal to 0, as well as x minus 7 equal to 0. By subtracting 2 on both sides, we get the first solution of negative 2. By adding the 7 over on both sides, we get our second solution of 7. So that one wasn't too bad. Okay, just required a bit more steps. Let me give you one to try. Let's say we have x plus 3 squared equals 16. Take a few minutes, pause the video now at this point, try the problem, and when you are done, turn the video back on and let's see how you made out. Well, the first thing that we're going to have to do here on the left side, x plus 3 squared. Remember, that's the same thing as x plus 3 times x plus 3 equaling 16. And so now, let's multiply together the left side. And if I do that correctly, I would get an x squared plus 6x plus 9 equals 16. Remember, we want to be able to use the zero product property, so I'm going to subtract 16 on both sides. And therefore now we would have an x squared plus 6x minus 7 is 0. And now we can factor. I'm going to set up my parentheses. Factors of x squared would be x and x. We need different signs inside the parenthesis. One will be plus, the other minus. And so now the factors of a negative 7 that would add up to a positive 6 would have to be a positive 7 and a negative 1. We can now use the zero product property, whereby, let's see what we're going to have to do here. I'm going to take the x plus 7, set it equal to 0, as well as the x minus 1, set that equal to 0. Solving, of course, now for x, subtract 7 over, and we get x is negative 7. For our first solution, adding 1 over, we get x equals a positive 1 as our second solution. Okay, so once again, that required a bit more work to get our equation ready for solving. Let's try one more. Let's say we had 2x minus 1 times x plus 4 equals x plus 2 times x minus 2. Now we have a lot of work ahead of us here. On the left side as well as on the right side, we're going to have to FOIL multiply first. So let's do that. Here on my left side, when we multiply things out and combine like terms, we would in fact get a 2x squared, a plus 7x minus 4. That is the left side of the equation when you multiply things together and you combine like terms. The right side, when we multiply things together, would leave us with an x squared minus 4. And so now, of course, we're done with the multiplying on both sides, but now we have to get one side equal to 0. So I am going to subtract x squared over, as well as I'm going to add 4 over. Combining like terms now, 2x squared and a minus x squared would leave us with x squared plus 7x. The negative 4, positive 4 will cancel, equals now on the right side 0. Now from a factoring point of view, this one isn't too bad. The only thing that we can factor is a common factor of x. By factoring out an x from the first term, we're left with x. By factoring out an x from the second term, we're left with a plus 7. And once again, now we have the zero product property being demonstrated, whereby now we would go and set each x equal to 0, as well as x plus 7 equal to 0. Well, there's nothing to solve here, but for the second one, I will subtract 7 over, giving me my final answer of negative 7. Okay, that completes Chapter 7. Okay, we saw here all the different types of factoring needed to be used. Okay, we talked about factoring trinomials, the easy kind, the hard kind. We saw factoring the difference of two perfect squares. We also saw factoring out a greatest common factor. Okay, all of those types of factoring skills are essential. Do take a look at the homework that goes along with this particular section, chapter 7.4. And as always, feel free to email me any questions that you may have. Until the next time, be well.